everybody, and welcome to Build Meets World, where I am joined today by
Phil Effler.
Phil Effler. So I'm at our test facility. You guys have probably seen me check in here occasionally or done a tour here, but we want to do this regularly with Phil because he's always got new cool stuff going on as it relates to testing. So Phil, thanks for joining me today.
No problem, Margaret.
Tell everybody a little bit about yourself.
Well, I've got a pretty big background in construction, as well as establishing laboratories. It's kind of been my thing for a good long while now. And now I'm here and I'm able to do great things with this laboratory.
So Phil joins us with a lot of experience. He's somewhat new to us. What is it, about a year and a half now? 2 years?
It's about it's going on a year.
Year and a half. So he came to us with a lot of experience, and we're so excited to have him here representing all the sophisticated system testing that we get to work with. So Phil, yesterday I was in Newark doing our Rising Stars program with David Hutchinson. So I want to do a shout out not only to David Hutchinson, but to the great group of people in Newark that might be watching us live right now. They can't wait to come and visit here. You know why? They think it looks like it's a lot of fun.
It is a lot of fun. We have fun here every day. We get to work on something new, huge projects, great collaborations, new products, everything.
So it's definitely fun. Somebody compared it to Universal Studios at once, probably not that much fun.
Okay, kind of set building, if you will.
I like it. That's pretty cool if you think about it that way. So once again, we're excited that you guys are all joining us today. Please submit any questions you have for Phil or myself in the question theme so we can address them while we're here today. We're going to be specifically talking about this stuff behind me right now. So I'm going to kind of zoom over here to kind of direct Phil and what he's talking about behind us. So Phil, take it away.
Sure. So behind me, we have our test wall. It's our main piece of equipment. These are kind of few and far between, but some people do have them. We have one ourselves, and we welcome anybody to come here, build a sample, and then do some preliminary testing. Air, water, and structural tests are what we usually run over here. Those include things such as ASTM, E283, 331. We'll run an IBC test, which is kind of a elongated version of 331, 2357. Those are probably our more common tests that we run. But we can crank this thing up and see where a specimen will fail too. So we can test the failure. We can go beyond what your standard specs are, which is really, really cool about doing that here.
Yeah. So I thought I'd pop back around again. So Phil, when we're looking at what we have going on behind us right now, do you always do both air and water testing on each sample? Is that like standard?
For the most part, yeah. I mean, passing air is one thing, but passing water is
another. So if you guys don't know the history about where we're standing right now today, we used to just test for air. So ASTM E2357 or 283, you might know those. Those are assembly tests. Phil mentioned them as well. And it's just focused on air. So now you're doing an air pressurization of your assembly, but you're not introducing water, right? So we wanted to do water too, because how many people call you and say my building is leaking air?
No one. It's my building's leaking water, or water's leaking into my building.
Exactly. I set you up incorrectly. But yeah, so that's what we're trying to look at. That's what we're trying to focus. We want to know if air is getting in, right? Because air can bring in moisture via vapor, right? So that can happen, but we also want to know what type of water and in what mode it's getting in and how quickly. So what Phil will be able to do is he can set this up to your specifications, meaning if you want to go to a higher pressure differential, if you want to go for a longer duration, that's what we want to be able to do with you is start to go and say, what is it that keeps you up at night? What are the things that you're concerned about or worried about as it comes down to your specific assembly? Come here, build it, and then let's go ahead and test it, okay? So what else do we have on this wall here? We got a couple different anchors I think we're looking at. I'll zoom us in a little bit.
We're doing some anchor testing here. So we're gonna basically spray both of these two samples with a ton of water and see if those are still watertight.
Yeah, so I think if it's something you guys can check out here, I'll kind of zoom you in a little bit further. So look what he's got up here, right? He's got different types of metal hat channel. He's got different types of anchors here. And you'll notice that some are with the air barrier, right into the air barrier, and some are going through the insulation. So why do we want to mix things up like that?
Well, you're going to have different styles of anchoring in the field, right? So we want to test every possible scenario. And that's something that can be done here in our facility.
And then having multiple options of detailing or configurations lends to the versatility that you guys can have when you're looking at your jobs, right? So you might have somebody that wants to switch an anchoring system on your project that you're not comfortable with, or that you're not used to, or you don't have a history with. That's where we can start working together. Especially, I mean, it has to include our products, of course, right? But that's what we can start working on with you. We also love this place to be a collaboration center. So we love to bring different people in. Different design professionals will come in, testing agencies. I know you use a testing agency a lot to come in and validate our testing. Tell us about that a little bit and what we do there.
Not only do we calibrate the wall with a third party, but we can also have a third party come in and verify what we're doing is correct and all of those things. So they'll offer you an independent third party certified report as well as ours. So we'll provide you one in addition to that third party report.
So it's just a perfect opportunity. I know we just got a question that just came in, so we'll try to answer that right now. Somebody's asking us, Phil, what is your most popular requested test? The water test.
331 is a very, very, very common test.
Okay. So just to kind of reiterate again, Phil mentioned the water test. We're looking at, when we do that water test, we're looking at a pressure differential, right? So we're pulling pressure, right? So water's going to cascade down the front of your panel or front of your assembly. And on the back side of this, we're going to try to pull that moisture through that sample so that we can see it on the back side, which would indicate a breach in your system, right?
We're pouring enough water on these walls to simulate twice the worst ever event we've ever had on the planet. So it's definitely going to come through if it's going to come through.
And I know a lot of you question sometimes, the validity of doing something to an extreme, but we can't get to these walls to maintain them, right? We can't remove the facade. I mean, we can, but we don't want to remove the facade to maintain it, right? I think somebody told me once that it could be almost $600 for 1 square foot. So if you have a lot of square feet that need to be removed, it can become pretty costly. So when we think about pressure, for someone that isn't familiar with the test itself, what are we looking at for miles per hour-ish?
I mean, it can range. Miles per hour, I would have to.
Yeah. So why is that important, right? So your building's going to have different levels of pressurization, especially if it's multiple stories or depending on where it's being built, right? So regionally, that's going to make a difference as well. As we start to see that wind loading, we want to make sure that we can address that concern up front and that we can say to you, based on the wind loads for your building, you now have the confidence level to be able to know how well your protection, which is these materials, are going to do for your building.
So the highest wind pressure or wind speed actually, because you mentioned miles per hour, is 217 that we've taken it to.
Holy moly, I didn't even think it was going to be that high. Oh my gosh, so no wonder he had to like disappear to get that exact number. So typically, if we're looking at code, now code that he mentioned is the IBC, right? So the reference in the IBC chapter 14, I believe. And someone will correct me when I'm wrong. That's the beauty of being live. That would normally include a facade.
Right.
So why would we want to do it without the facade?
Well, you can see where your wall's going to be, and at any point in that wall system, it could fail. So again, we like to test to failure. We like to see things that normally you wouldn't necessarily see. So we'll crank up the testing to get every ounce of information that we can out of a specimen.
And that's where that customization that you can provide for your sample, right? So you want to say, I want to see the standard, which would be 300 pascals, which is 6.24 PSF, which is like 70, no, is that 25? 25 miles per hour. That's not a lot. So he takes it up to 217 miles per hour, right? So not always, not everyone wants to see it at that level. A lot of times we might do it just so that we can see where those points of concerns might be on your assembly, right? So when you picture that whole team coming in here together, there's a lot of lessons being learned, right? So they can start to go, wow, I get it now. If I don't do this right here, this is what potentially could happen. So that's what's pretty interesting. when we bring it to this level and to work here. Now, what we have here, like you said, we're working on a couple different fasteners. That's probably the most common thing, would you think, that a beyond the water test, what's the most commonly submitted test that people want to see in terms of the wall?
I think they want to see things that are more particular to what they have going on, right? So it's what they're currently using, or what a project is currently, something that's project specific. So we'll come in and we'll build an assembly and test what you have going on right now.
So I think that's important, right? So project specific testing is done here so we can make it specific. If you looked at a data sheet, even ours, it will say ASTM E331 pass. So that's with the air barrier. Now that's important because you want to make sure you have a robust air barrier that can pass. But it actually is a bit misleading, right? Because what else is going to make an impact on your assembly beyond the air barriers? The facade anchors, the detailing, the window connection, everything forward of that, right? So that's why we have this facility and the ability to work with Phil to once again look at your project specific connections and details. So that's kind of gives you like that overall view of why we're here. I know we just got in another question, so I want to make sure we address that. Phil, how does somebody go about submitting a test if they have one?
Well, I mean, you can reach out directly to any of us, but probably contacting your closest rep will do just fine. They'll get contact with me or Marcy or submit a test request properly.
I think we had several coming in recently. I still get copied on them, and I just know Phil takes care of them, so I kind of ignore them. But I know there is a bunch that have been rapidly coming in late. So
our air barrier guys are very busy.
they are very busy.
One particular one.
Really?
Yeah.
Okay, multiple from one guy, so I'd like that. But yeah, so if you have something in mind, we always want you to start with your sales rep. The sales rep's going to help guide you through this process anyway. You probably already have one that you work with. If you don't have one that you work with, you can also reach out to me or Phil, as you mentioned, but we do have a guide online on our website where you can find your rep. It's probably just going to be easiest if you don't have a rep to reach out to one of us. That way we can connect with the right rep anyway, because we've got lots of reps these days. We got lots of feet on the street, lots of people that are here to help you on your project. And that's what's so important. So not only doing this project specific testing, but giving you advice based on your project specific needs. So obviously if you're building on a coast, if you're building in a seismic zone, if you're building 16 stories or 2 stories, that's where your rep can come in and help you specifically not design, but make sure that you're looking at those design considerations that you need for success, right? Perfect. Okay, so what we talked about was air. So it's not really exciting to see air going, right? Even though we can get this thing going pretty high when you think about that pressurization that occurs. But then we start doing the rain, right? And that's part of the ASTM 331. So it's got nozzles up here. We've got that nice drainage plane that's going to occur on our air barrier surface. We get that continuous film. I think it's like 8 inches of water per hour is what we do. And like Phil said, it's more water or more rain than your air barrier or your detailing is ever going to see. But you want to know how something's going to react if that should happen. So what we got here, once again, is a lot of fastener testing, but we'll do windows, so specific windows. And then how about different types of movement joints?
Sure.
Let's do that. Nice little segue for us to introduce this super tall sample we got here. So that gives you the versatility just to kind of kick us off with knowing that no matter what you want to address, we can make it fit. And that's why we have a 2-story wall. So what do we got going on here?
This is a seismic drift joint. So what will happen is in a seismic event, you'll have a lot of shaking and whatnot. Everything's just kind of going crazy. But what we have here is an isolation joint above that window, a drift joint, where that moves independently of that window and saves the glass from basically breaking out of your building.
So you guys can see the scope of it as I get closer to it. And it's pretty
big wall.
It's a big size, right? So there is, I would like to say very little in terms of limitations here, but that's why you need to talk to Phil, because there's different ports on the wall. There's different things we're looking at. And how about the weight of things?
Sure. Sometimes with certain requests, yeah, we do have some limitation on weight, size. We can't go on indefinitely, but we can do a pretty good size specimen, 2-story, double wide. again, a lot of capabilities here in this facility.
And if you're interested in knowing more about this one, stay tuned for us because we'll share in more detail what's going on. But I know there's a video of Phil on our LinkedIn page right now of him showing that what we adapted here in terms of being able to demonstrate the movement that you're going to see up there. Now, once again, if this is a project that's specific, they're going to tell us they want to see 1.5 inches of differential movement. They're going to tell us what they want to see in terms of pressure differentials that equate to that wind speed or the amount of duration that we're going to do it in. There's standards, but we always will share that with you and say, what's keeping you up at night and what do you want to evaluate further? So this one will be a really cool one to continue to see. So stay tuned and stay tuned for more of this. So speaking of weight, when I handed over the keys to the facility to Phil, we left him with something else, a really heavy specimen that's outside right now. So is it still out there?
It is. I'm still trying to get rid of it.
He's still trying to get rid of it. It's the gift that keeps on giving. So, but that's just in a funny way to say, we were looking at an insulated concrete form, right? So we had the insulation, we had all that thermal mass provided by the concrete in the middle. But those are all the things that are specific that Phil will talk to you about, right? He will talk to you about what is your end goal of your test. Maybe it doesn't have to be as huge as this. Maybe we can isolate your concern in smaller samples. Maybe there's some things we can look at. I think what I'd like to do maybe a shout out to people is we haven't had a lot in terms of like roof to wall interfaces. So maybe something like that might be really cool for us to look at. I know several people have wanted to see some interactions with like brick shelf and ledges, and what does that do when you start loading that with different levels of weight when we start to look at air barriers. But there's really there's so many opportunities. We've been here doing this for a long time, but I think we still continue to learn stuff and still have lots of opportunities to engage with people.
I learn every day. It's this facility, you can't not learn something.
Right. Is that right?
Possible. No, every day we're doing something new and something exciting.
So definitely stay tuned on all of that. I know what we're going to start looking at is ways that we can share what's going on here even more often. So stay tuned for that. And there's not only Phil, but he works here with a couple of individuals that are working on a variety of different things. Not only things that you can see, physically see, but some things that are in terms of modeling too. So we're going to take you to that level of really understanding like how the modeling plays into then seeing how it reacts to what we have here. I know a lot of the stuff that's coming in on a regular basis keeps you guys busy. Is there a time frame that you usually suggest that it might be for somebody if they submit something?
Well, that all depends on what materials we're working with, right? So sometimes different materials have different cure rates. It could take 1 week, it could take a month, it could take 2 months per se. By the time you build specimens and then turn around and stage them and then test them and then the report out. So sometimes it does take some time, but we do our best to definitely facilitate where we can and get that information back.
So and that's what's important too. When you have that discussion with your rep, it'll then turn into a meeting with Phil and to others to talk about what your project needs are. So be honest in terms of your timeline, and then Phil will start to talk to you about what can be done. Now, I know panelization is big in our industry. A lot of people build their stuff and send it here, right?
That's an option too. We'll work with you in any way that you want. We've done specimens that are 4 foot by 8 foot, 8 by 8. We can send you a specification on how to build the exterior buck if you want. That way they fit on our wall. Just about any way we can help, we will.
And I see we had another question that just came in about, can we come here, right? And of course they can come here, right? 100%. You can come here and work here directly with these guys. So all of those things will play into your timeline, right? So if you're going to send us something that's already built and ready to go, that means the materials are cured, they're dried to the level that you want them to, then we'll go ahead and do that. So that's where that coordination with your local rep and with Phil will help with that. You can also come here and build with the guys, right? So that's just an option too. And I know a lot of people like to do that because they want to test their skills on building it, and that way we're testing their installation versus maybe what we would do from an install perspective. Sure. The other thing that I think is really cool and interesting is if you do build it and ship it to us, especially if it's a panel, that's what it's going to do anyways, right? You're going to build it in your shop and you're going to ship it. So you're going to build it, ship it, and maybe there's some movement that occurs in that shipping that is now being validated when it gets here to be tested. So that's kind of cool too. I know we've done some exposure testing too, so maybe we test it now. We slide it outside, we let it be exposed to Cleveland weather, which today was pretty extreme.
It wasn't bad, but yeah, we actually just completed the weather test.
You did? What were you working on?
We were working on our fourth.
So we should here at 4:30, seeing how it is evaluated at time 0 and then exposed is really cool. I know we got some other samples that have been sent in, like from insulated concrete form, our insulated concrete form from Endurance. You can take a look at that. So those are things we can do too. So there's lots of options, and we want you to feel like this is a collaboration point. So we've even had people come in with their ideas for testing. We validated it all together. Whether or not we bring in a third party to validate it is a conversation we have with you, because it depends on what you're going to do with that information, right? Do you need it third party or is this more educational? And then they present this information at different industry events. So that's always an option too. We love being able to educate people on the findings, and that's what we're trying to do with this team now, is how do we get them up in front of people so you see what they're learning and what they're discovering here. So it's pretty cool. Awesome. Okay, well, I think we don't have any more questions that are coming in right now, but we're always available to answer any of your questions at any time. But what we really want to reiterate again is come back and see us, because there's always something new. We had to stop Jake, the other guy that works here, from all the work he's doing on some of these other samples behind us. We've got stacks and stacks of samples over here. So there's always something new to see. And we also have more lab space with different things going on a regular basis. So we definitely want you to come back, check in with us. This whole month, Phil, on Build Meets World is all about testing. So we wanted to kick it off with Phil and all the stuff that they do over here at the test facility. And then next week, we're gonna move into storm shelters and how they evaluate storm shelters and why storm shelters are so important. Then we're going to go into different ways to do horizontal waterproofing. So that'll be pretty cool. And then we're going to close it off with some building enclosure testing in the field. So stay tuned.
Exciting topics.
Yeah, stay tuned. April is all about testing, and we're so excited that you were able to join us today. If you have any specific questions, you can always reach out to your Tremco rep, or you can email me at mtyler@tremcoinc.com. Thanks.
Have a good day, everyone.